As you can see, today we're going to do 5-5 continued, meaning all we're going to do is try to add on some new types of problems from the material that we did in 5-5. As a reminder, we have theorem 5-5-3 is the triangle inequality theorem. And in summary, basically this theorem says that if you add two sides of a triangle, that length will be greater than the third side. We'll be doing all of these new problems primarily dealing with this theorem. So let's see, if I were to draw a triangle here, we can call it triangle A, B, C. What this theorem says is that the length of AB plus the length of AC will be greater than that last side, which is BC. And it says it for the other inequalities as well, but we'll be using this idea of writing inequalities like this for this new type of problem. A new type of problem would say the lengths of two sides of a triangle are 22 inches and 17 inches. Find the range of possible lengths for the third side. So what we're trying to do is find how long that third side could possibly be. Not a definite number, but a range of possible solutions. So we're going to use that theorem, and we can say, let's just call S is equal to the third length. You don't need to write this every problem. You will be using a variable, but for this one I'm just trying to show you each step. So what we could say is that, well, 22, because that's one length, 22 plus this new length of S, this has to be greater than 17, right? We add together two of our lengths, 22 and S, and it has to be greater than the third side. And we can also say 17 plus S has to be greater than 22. Again, for the same reason. We're adding one side plus another side has to be greater than our last side. And lastly, we actually have one more. 22 plus 17 have to be greater than S. We have 22, which is one side we know, and 17, which is what we know, has to be greater than this new one. And now we just go ahead and solve each of these inequalities for S. So this first one, we're going to subtract 22, and we see that S is greater than -5. Let's do the second one, and we subtract 17, S is greater than 5, and then actually the only thing we have to do here is add these two numbers together, so 39 is greater than S. Or in other words, as I said, I like to flip, S is less than 39. So now we have S's, we solve for S in all of these, and we see we have S is greater than -5, S is greater than 5, and S is less than 39. Well, this first one doesn't make much sense because it's talking about the negative, so we're not going to talk about this one at all. Instead, S is greater than 5 and S is less than 39. That's a good range. So our answer simply is between 5 and 39 inches. Because that is that's the range where S falls in, is that anything greater than 5, but it also could be less than 39. You could also express this just fine as 5 is less than S is less than 39 as a compound inequality. If you didn't want to, that is fine, but this is how we solve this new type of problem. A similar problem to the last one says that the three expressions are lengths of the sides of a triangle. Find the range of possible values of n. So these three expressions, n, n plus 2, and 2n plus 1, are the possible side or the lengths of the sides of a triangle. We need to find what n is. And we're going to do a very similar process to the last problem because we know they're in a triangle, so we can apply our theorem. We say that n plus 2, all I'm doing is taking two side lengths, the first and the second. I'm not going in any special order. I'm just doing the first and the second. N plus 2 has to be greater than this last one. So it has to be greater than 2n plus 1. Okay. Let's go ahead and solve this. We see 2n plus 2. All I did was simplify. N plus n is 2n plus 2 is greater than 2n plus 1. Now solving for n, we're going to have to subtract, well, if we subtract 2n, we're end up going to get 2 is greater than 1. That doesn't make much sense. That doesn't help us very much. What this tells us is all real numbers, but it doesn't help us, so we have to move on. Let's now do n plus 2 plus 2n plus 1 is greater than n. All I did was I added the second and the third. It has to be greater than the last one, which is the n. Let's simplify. We have 3n plus 3 is greater than n. Added together 2n and n, which is 3n, and then 2 and 1 is 3. And now we solve. Let's subtract n, 2n plus 3 is greater than 0. And then I'm going to move this up just so you can see it. We have 2n plus 3 is greater than 0. And now you subtract 3 to get 2n is greater than negative 3. And as you may notice already, this is not going to make much sense to us. It's saying that it has to be greater than the negative number. That's not very helpful either. So now finally let's move on to our last situation, which is, let's see, we added the first and the second and the third. So now let's add together the first and the third. N plus 2n plus 1 is greater than n plus 2. Same process, or same reasoning. I added the first and the third, and it has to be greater than the second then. So now we have 3n plus 1 is greater than n plus 2. Simplifying now, we subtract, let's subtract 1 from here. Subtract 1. 3n is greater than n plus 1. And now move the n over, and you see 2n is greater than 1. Last step, you need to divide by 2. N is greater than 1/2. Now, of all of our answers, 2 is greater than 1, n is greater than negative 3/2, or n is greater than 1/2. N is greater than 1/2 is the only one that makes sense. So actually, our answer here is only one answer. We only have one inequality, and simply n has to be greater than 1/2. And that is our answer here. A little bit different mentality, but you're still using the same process. So anyway, good luck with this. And of course, if you have any questions with this, write those in your notebook and make sure to ask in the morning.